More than 300 million years ago, long before the dinosaurs, Earth was dominated by vast swampy forests and an atmosphere richer in oxygen than today. In this environment, arthropods, animals with exoskeletons and segmented bodies that made up the ancestors of today's insects, crustaceans, and arachnids, reached extraordinary sizes. Among them was Arthropleura, the largest land dwelling arthropod ever discovered. Reaching up to 2.6 meters, over 8 feet in length. This massive, many legged creature resembled a colossal millipede and likely played a key ecological role in prehistoric ecosystems. Hello, everyone. Giant Stonehead here. If you enjoy obscure science and forgotten history, please feel free to like, comment, and subscribe. And now, let's talk about some big old bugs. First clues to Arthropleura's existence came from trace fossils, specifically enormous trackways preserved in ancient sediments. These trackways, some exceeding 50 centimeters in width, were found in Europe and North America and suggested a creature far larger than any known arthropod. Early paleontologists struggled to match these traces with a known organism. Body fossils of Arthropleura are comparatively rare and often fragmentary. Most consist of isolated exoskeletal plates or segments, which complicated efforts to reconstruct its full anatomy. For decades, scientists debated what the creature looked like, particularly its head and feeding structures. A major breakthrough occurred in 2024 when researchers used high resolution imaging to analyze exceptionally preserved fossils from France. These scans revealed long missing head of Arthropleura, showing a fascinating combination of anatomical features. The head bore similarities to centipedes, while its segmented body resembled that of millipedes. This discovery clarified its evolutionary relationships, showing that centipedes and millipedes are each other's closest living relatives, and it provided new insights into how Arthropleura lived. Arthropleura is the largest terrestrial arthropod yet discovered. Estimates based on fossil remains and trackways suggest lengths ranging from 2 to 2.6 meters, or 8 feet. Body consisted of numerous rigid segments, each equipped with a pair of legs, giving it a broad, flattened appearance. The exoskeleton was thick and protective, composed of hardened plates that provided structural support and defense. Like modern arthropods with specialized appendages for predation, Arthropleura lacked such features such as large mandibles or venomous claws. This anatomy suggests it was not an active hunter. The many legs of Arthropleura would have enabled steady, deliberate movement across the forest floor. The wide spacing of its trackways suggested a slow but stable gait, similar to modern millipedes but on a much larger scale. Arthropleura lived during the Carboniferous period, roughly 345 to 290 million years ago. This era was defined by extensive tropical wetlands, dense vegetation, and high atmospheric oxygen levels, conditions that supported unusually large arthropods. Carboniferous landscape was dominated by giant ferns, lycophytes, and early trees, forming thick, humid forests. Layers of decaying plant materials accumulated on the ground, creating ideal conditions for detrivores. Fossils of Arthropleura have been found across what are now parts of the United States, the United Kingdom, and continental Europe, regions that were situated near the equator during the Carboniferous. High oxygen levels are traditionally cited as the key factor enabling arthropod gigantism. Arthropods breathe through passive respiratory systems, which is to say, they don't typically have lungs or closed circulatory systems that transport oxygen like ours does. Thus, the increased oxygen concentrations may have allowed them to sustain larger body sizes. However, recent research suggests that oxygen alone may not have fully explained the scale of Arthropleura, as at some points when the species existed, the oxygen levels weren't much higher than now. Abundant food resources combined with the relative lack of large terrestrial predators likely combined in and contributed to its success, showing that body size can result from complex interactions of biology and environment. For many years, scientists debated whether Arthropleura was herbivorous, omnivorous, or carnivorous. The discovery of its head structure has provided strong evidence that it was a detrivore, an organism that feeds on decaying organic matter. Diet likely consisted of leaf litter, rotting wood, and possibly fungi. Carboniferous forests produce vast quantities of plant debris, making detrivory a highly viable ecological niche. By consuming and breaking down this material, Arthropleura would have played an essential role in nutrient cycling, similar to modern millipedes and other decomposers. This feeding strategy also helps explain its large size. Rather than chasing prey, Arthropleura can sustain itself on abundant, low energy food sources, allowing it to grow large without need for speed or complex predatory adaptations. Arthropleura belongs to an extinct group of known as arthropleurids, which are closely related to modern millipedes. However, its anatomy reveals a mix of characteristics not seen in any single living group. The combination millipede like body and centipede like head suggests it represents an early branch of myriapod evolution. Makes Arthropleura particularly valuable for understanding how arthropods adapted to life on land. During the Carboniferous, terrestrial ecosystems were still developing, and many modern groups were in the early stages of diversification. Arthropleura provides a snapshot of this transitional period, illustrating how different anatomical traits coexisted before becoming more specialized in later lineages. Its existence also reflects a broader pattern of gigantism among Paleozoic arthropods. Other examples include giant dragonflies and large scorpions, all of which thrived under similar environmental conditions. Studying these organisms helps scientists understand how atmospheric composition, climate, and ecological dynamics influence body size. Despite its success, Arthropleura did not survive beyond the early Permian period. Its extinction coincided with major environmental shifts, including the decline of Carboniferous rainforests. As the climate became drier, the lush wetlands that supported the dense plant growth began to disappear. This habitat loss would have reduced the availability of decaying plant material, directly impacting detrivores like Arthropleura. At the same time, terrestrial vertebrates, particularly early reptiles, were becoming more diverse and widespread. These animals may have introduced new ecological pressures, introducing predation and competitive pressure. Combination of environmental change and biological competition likely contributed to the disappearance of Arthropleura. Its large size, once an advantage, may become a liability in a changing world with fewer resources and more threats. Generally, species can withstand pressure from one direction, but pressures from multiple directions tend to push towards extinction. Today, Arthropleura stands as one of the most striking examples of prehistoric life. Its immense size challenges modern assumptions about the limits of arthropods and highlights the unique conditions of the Carboniferous world. Ongoing research continues to refine our understanding of this giant. Advances in imaging technology, including CT scanning, have allowed scientists to examine fossils in unprecedented new detail. The 2024 discovery of its head anatomy underscores how well known organisms can yield new insights with improved methods. Beyond its scientific importance, Arthropleura captures the imagination as a symbol of Earth's deep past. It represents a time when ecosystems operated under very different rules and when life experimented with forms and scales rarely seen today. Well, what do you think? Would you like to hear about more ancient insects and bygone ecosystems? We might cover more of Arthropleura's contemporaries in the future, such as the giant scorpions and the giant dragonflies. Feel free to like, comment, and subscribe. I'll be posting here weekly. Thing you'd like me to cover next? Let me know. And until next time, thanks so much for watching.